Good afternoon, everyone. Dylan's just had to reboot his router, so apologies if there's a little bit of confusion, but Dylan will be here to help me out shortly, I'm hoping. For those of you who aren't in Sydney, you're missing a beautiful Sydney afternoon, a lovely warm winter's day. Alright, so where are we at with COMP2041 and COMP9044? This is week 3. Our last students are into the course, hopefully. Hopefully you all submitted week 1 and 2 labs. If you by Tuesday, there's a small. I think you can still submit them with a small penalty. So submit them if you haven't. The lab exercises for weeks 1 and 2, they have to be submitted with give to get marks. That's how it works in this course. There are labs this week, and they'll be due noon Monday. From now on, things will be due Monday. We've sort of had all sorts of odd deadlines with long weekends and the start of the course. What else is happening in the course? We'll have an assignment out soon. Your first assignment will involve shell scripting, but as you're just writing your shell scripts, it's a bit early to get it out. By the end of the next lecture, maybe we've covered enough for you to start the assignment. Right. Dylan's rebooted his router and managed to join me. Welcome back, Dylan. So, weekly tests. Our weekly tests start this week. Weekly tests are something I created. So some of you might have encountered them in courses I've taught previously, like COMP2041 and COMP2041. They run slightly differently to they do in COMP2041. I'll explain how. Some of you haven't done any of these courses, particularly students in COMP9044. So let me explain a bit more details for you. So forgive me if you know a bit about weekly tests, but some students know nothing. Weekly tests are meant to prepare you, well, for the exam, but not just for the exam. They're meant to give you practice at coding under time pressure, which happens sometimes when we're fixing problems. You know, there's a server's broken and there's a lot depending on it and it has to be fixed. More likely in your future is an interview situation where you're expected to code to get an internship or a job or demonstrate your proficiency in a very time-limited circumstances. So it's also preparation for that. So weekly tests, there will be several questions. In fact, I think it's 3 questions every week. There'll be programming questions. There'll be exam-like programming questions. Sometimes they're taken from old exams when we decide an exam question wasn't that great, or people have seen it. Well, it gets retired to a weekly test. There'll be auto test and there'll be give. But more than that, you shouldn't start the weekly test until you've got an hour set aside. So weekly tests are meant to take an hour, and it's all about seeing what can you do under exam-like conditions in an hour. No help, just you, computer, problem, go. One of the things I like doing this is students, we give you a lot of help, tutors in the labs, course forums, you work with each other. That's great, but you're left in a bit of doubt about how much you know yourself. So there are reality check to work out how much you know yourself and what maybe you need to improve. So a bit of feedback to yourself about what you really know by trying to do things just yourself. It's a bit easy to fool ourselves, with getting a lot of help. You think, oh, I would have worked that out. But would you? Well, find out. A weekly test. All right, so we release the weekly tests every Thursday. I think we'll release them maybe 5-6 o'clock, but it doesn't matter much because you have to set aside an hour any time in the next 7 days. So you can set aside an hour any time in the next 7 days to do the test. Now, please don't panic if you can't do all 3 questions in an hour. The tests are designed so they're exam-like. So if you can do, 2 of the 3 questions, that's great. I'm really happy. You're with most of the class. You're doing really well. You can get a decent mark in the course. You can do 3 of the tests, and that's fantastic. Maybe you can get a distinction or HD in the course. At least you're on track for that. If you can do 1.5 questions, that's okay. You've got to keep working, but you and 100 other people are in that situation, maybe 200 other people. you're finding the course not so easy, but it's not so easy. If you can't do any of the questions, you can't even get one question solved by yourself, no help, then then it's time to think, what more can I do in the course? What I'm doing is not enough. I'm falling behind. I'm not mastering the material. So I've got to do something. Revise, extra help, whatever. So that's how it's meant to give you feedback. There are marks associated, but honestly, there's partial marks. It's all set up so that if you're getting 2 out of 3 questions, it's going to make it. You're going to get almost all the test component anyway. There are 8 weekly tests. Your marks form from the best 6 of them too. So you can have 2 bad days and they just get forgotten. It's if you do all 8 weekly tests. So best 6 of 8.
Admitting
so we always
after the hour.
Yes, thank you, Dylan. Yes, we always get the question, I want to keep going, Andrew. I could have got the question 3 out given more time. You can keep going, and anything you submit after the hour, that question gets half marks at most. So you submit a correct answer to question 3 after the hour, you can still get half marks for it. So that's fine, but I'm really interested. I think it's really important to see what you can do in the hour under time pressure by yourself to give you this honest feedback of how you're doing. Are you okay? You got 1.5, 2 questions out, you're okay. Or 2.5 questions out, you're great. But this honest feedback to yourself. And if you want to then keep going, and spend a few more hours solving another question, that's fine. But again, remember my advice. Please don't fail maths because you spent lots of. You can get some of this if you like me and love coding. Spending time on these questions is easy and fun, but failing maths is not fun. So make sure you allocate your time wisely in the short time frame of the UNSW term. Tim's asking, is it pass-fail? No, the auto marking, it's set up so the auto marking will give you partial marks. I disagree with Blake. Maths is fun, but I wouldn't say necessarily easy. Yeah, link goes up to 9. Someone's asking if we can get more places in COMP2040. Sorry, I would love to. Yeah, you and 200 other people want to get into COMP2040. Because of the way COMP2040 is delivered, we can't get more people into 6080 at the moment. In fact, it's a battle to get COMP2040 available to students. So anyway, that's a complete aside, nothing to do with this course, except COMP2040 is the natural follow-on from this course. I guess I would say, by the way, the corollary there is if you love that sort of stuff, get in early to COMP2040. All right. Now, don't panic about the weekly test. If there's any issues with it, you've got no need to do it before next week. You've got up until Thursday, and you really only want to set aside an hour for it. I would say unless you're really doing well with the material, it's probably better to wait until you've done this week's tute and lab, just to get a bit more. The weekly tests are meant to be last week's material, but still, doing this week's material will generally help you with last week's material. So there's no need to rush into the weekly tests. Yes, weekly tests are coding, and more coding. If you don't like coding, I'm so sorry, you've chosen the wrong course. There's just so much coding in this course. All right. Now, let's talk. Unless Dylan's got something I need to be talking about, I think I need to talk course content. Dylan's shaking his head, so let's go talk course content. Actually, I'll come back. I think let's. All right, we're going to recap a few things and look at them perhaps in a deeper dive than we're out to. I rushed the last lecture because we needed to get through that material for this week's lab because Monday was a holiday. So on screen is a little shell script. I've called it L. I'll explain why. It doesn't have a suffix. I would generally suggest putting a suffix on shell scripts perhaps, so it's clear what they are. At the top there's these 2 weird characters, a hash and a bang there, hash and exclamation mark. That's a Unix thing where the operating system, if you ask to execute a file, looks at the first 2 bytes, and if it has the ASCII value for hash and the value for exclamation mark, we'd call that a magic number. But if it has those 2 values, it then realizes this is interpreted code. I need to run a separate program, and it will figure out what to do with the contents of the file. This can be absolutely any program. A common thing to see there would be Python, Perl, Ruby. But in this case we say, look, no, operating system, this is not machine code. This is things to pass to this program, bin sure. The commands there say run the ls program, which you're familiar with. A couple of options for ls, my favorite options for ls. And that says dollar is the thing for shell variables. That weird syntax, double quotes, dollar at double quotes, gives you the shell, the arguments to the program in the way you almost certainly want. Why is a little bizarre. We don't need to worry about it too much, but you'll be writing this a lot in your shell scripts. Alright, I can run this script here, and it does that. It shows me the files in the current directory. The -L gives me a long listing. The -A I think shows hidden files, so I see, well, what do we mean by hidden files? It shows me anything starting with dot. So ls hides files starting with dot because they might not be interest to me. And this is a great example. This is a file starting with dot that I probably don't want to see when I'm looking at files. It's a temporary file for the editor. And what does the S option do? I've actually forgotten what the S option does, but you can look that up in the manual entry. Alright, now why would I do that? Well, this is actually something I wanted to show you. It's a common thing for people to do, to write these tiny stub shell scripts that do almost nothing, just as a convenient way of giving them a shortcut or an alias. It's not the only way to do it, but it's a very easy way to do it. So now I can type L rather than typing ls minus las star. Ooh, that's not what I wanted to do. I wanted this. Ignore that. Now this only works in this directory. So only when this I've put this file in this directory, it only works in this directory. I can make it work anywhere though, by putting it in a directory in my path. So here's a pretty typical Unix-like system path. If you look at your path on a CSC server or lab machine, you'll probably see something like this. It may vary a bit, but something like this. This tells the shell where to search for programs. So that says search this directory, this directory, this directory, and this, and your current directory. We talked about that in the last lecture, how this is a little dangerous. It's quite convenient when you're doing development work to say, if I say run a program, look in the current directory, maybe it's something I've just compiled. So, and it's probably okay for us, but Dylan pointed out that if you're the super user, if you're root, you wouldn't do this because of the accidentally running a program you didn't mean to, with super user privileges, which could do bad things. So you're thinking, all right, Andrew, you'll copy your program to one of these directories. Oh, why is that? Well, we can work out why it is. So that's a symbolic link that says on this system there is no bin directory. Well, this says if you want bin, go to user bin. That's a common setup these days in Linux systems. CSC systems, I think, will move to that next term. So if we look at user bin, it's owned by the super user. Only the super user can put files in it, which is a very good thing. I can look in the directory, but I can't change it, so I can't put my files there. The common recourse is something like this, is to maybe create a directory called scripts or bin. We'll make one called scripts. Oh, let me show you something. CP is actually bad design. It doesn't copy file to permissions, which you probably want to do. The P option on CP copies the file permissions. Should have been a default. Crazy it wasn't the default, but we live with that. So you say cp -p to copy file permissions, and that saves me having to go to the new file and change the file permissions with chmod. I can verify that if you like. And I can add that directory to my path. Something like this. If I wanted it at the front of the path, I would do this. And now that directory will be searched every time I run. There is a problem though. I've only changed that variable for this shell. So if I change an environment variable, it's changed for this shell and anything it launches. So in variables are not system-wide. They're only for this shell. So what do I do about this? And what about next time I log in? How do I change it for next time I log in? That's a little bit system specific. I think at CSE there's a file called bash login. Is probably the one you'd change in the top directory. You could set your path in there. All right, 2 words of advice if you're setting a path. Include anything that's already in your path supplied by the system. So don't set it, say, oh, I'll use the system path plus this directory I'm adding. The other thing would be, if you really break your path, you may not be able to log in, which is a little scary. So my trick would be log in twice, and then change the path in one window, log out, and then log back in again. And if all's good, you're right. If you can't log in, then undo what you've done. All right, so that's something for you to play with if you like and think about. You can ask your tutors about that as well if labs have got some quiet time. All right, that's searching the path. That's a little shell script. What have we got to show you now? All right. So a for loop in shell. For those of you who've programmed in C, shell for loops, nothing like C for loops. For those of you who've programmed in Python, you've got a bit of a leg up here. A shell for loop is quite a lot like a Python for loop, except syntax. Well, Python's weird for syntax. Shell has old school, really old school syntax. I actually like showing students seeing this. There are so many possibilities. So there's a thing where you get taught one programming language or even 2 programming languages, and you think that that's the way it has to be, but it isn't. There are many choices, many of which are arbitrary and trade-offs. So it's lovely to show you more programming languages which have made different choices. So rather than brackets, shell for loops start and finish is marked with different words. So a shell for loop has 4 keywords: for, variable, keyword in, do, and done. And here is, like Python, a list of values. Well, in shell it's probably better described as a list of words. Now, what does this do? This executes, this is a, is that a regular expression? That was a huge point in the last lecture. So no, that's not a regular expression. It's something, it's a little simpler than a regular expression. It serves the same purpose, but it's a simpler language with overlapping characters, some of which do the same things, some of which would do different things. That says match any file name that ends in .c, a literal .c. So that will create a list of words for containing every file name that matches that, and then this directory, it's those 3 files. So that loop will execute 3 times. And we will run the program. try and run the. I don't know. Don't know what that is either, coming out of my shell history. And there's the program run 3 times. Beautiful. Also demonstrating built-in arithmetic in the shell. Not the prettiest thing. If you need to do a little arithmetic, it's okay. If you do a lot of arithmetic, you should be asking yourself, is shell my right choice? And that's a big theme for this course. Well, that's not so much a theme, it's a goal. It's a goal. I want you learning more about, what, you've got an internship and your manager says, we need a program to do X, and you've got to say, well, I know Python, I know C, I know shell, perhaps I know some other languages. Which one should I choose? Little arithmetic, shell's okay. A lot of arithmetic, probably not. Lots of running of other programs, lots of redirection of output or connecting other programs together. Yes, shell. Complicated control. No, not shell. All right. Was there something? Oh, all right. Yeah. Don't panic about this, and if you're freaking out, you don't have to worry too much about this. But there is. Oh, I don't want to remove those programs. There is something to be aware of. How do we make this? We'll make this execute once for every Rust programs end in RS, don't they? What does that do? This is something to be aware of. There are ways of changing this, but by default, globbing, this file matching, does what you'd want probably as an interactive user. It's not what you want as a scripter. So this is where shell is letting you down. Shell is doing something that's suited to someone typing on a keyboard, not suitable to running in a script. So star.s, if nothing matches, becomes a single word star.s. This script would prefer it became nothing. That is possible. So this loop executes once for star.s, and it tries to do an ls-l of star.s, which doesn't exist because there's no star.s files in this directory. That's something to be aware of. There are workarounds, but really what my message is, be aware of what that does if it doesn't match. So if you see this, you can think about the workarounds. Okay, let's move along to my next, the world's shortest, well, equal shortest useful C program. So I mentioned bin true and bin false in the last lecture. I didn't have C implementations. There you go. There's C implementations. You can translate it to Python if you want. But the bin true returns 0. Beautiful. But wait. Bin false. Oh, what happened to bin false? Bear with me. There we go. Returns 1. So an exit status of 0 indicates things went well. Non-zero statuses indicate a problem. So there's bin false indicating a problem. That's not quite bin false. There's a weird operating system out there where that won't work. I think there's only one weird operating system which is almost dead where that won't work, but near enough for our purposes. Bin false. Why? Yeah, I'll show you why in a second. I wanted to highlight something. Oh, okay. Oh, I know what it is. It's sorting, isn't it? Anyway. This one, this program. All right, we saw this before. This is echo implemented in C. Now you might be saying, oh look, Andrew, that always exits with status 0. It's not quite true. I just wanted to point out that there is another way for a program to exit other than return. Well, there's multiple ways, So sure, if the end of main is reached, the exit status of this program is 0. But it's possible that one of these library functions here could call exit, say, 1. So buried in these could be exit 1. Or the other possibility is the operating system could just terminate the program, which would also produce a non-zero exit status. So if things go wrong somewhere in the program, we may get a non-zero exit status. We'll talk about more about why that's interesting, why that matters, how you handle it. Yeah. All right. This is my counting program. How does it work? I can't actually remember. I think I say count 1 to 100 in steps of 7. No. Should work. I'm not sure why. Why isn't that working? What is my bug here? How do I find my bug? Well, I didn't know there was a bug here. Let me show you a bug finding technique. There's 2 ways to do this. Actually, I'll show you the other way first. Well, actually, no, this one's more useful. I like this one. You can say set -x and it shows you execution. Yeah, I could just look at the chat to see what's happening, but so I'm sure someone spotted it. Oh, I spotted the problem myself. Whoops, I'm an idiot. Alright, there we go. So I've called this program SEQ because there is a built-in, incredibly useful built-in program which I wanted to bring your attention, called print a sequence of numbers, and I haven't quite matched its semantics. So that will do what I want. If I change that. Notice here I get show on the execution. The -x flag says show me every execution you do, and you can see it down here. Quite useful turning it on in the script, because maybe you know this code is great, but you know the bug is down here, so you might turn it on here just to see what happens from here on. Alright, so we didn't need to write this script. It wasn't because there's already a built-in utility that does something like this. But it was good to show you use of test. Test is useful for conditions. It's a program that exists only to have an exit status. It looks at its arguments and it exits with status 0 or 1 depending on its arguments. So $# is the number of arguments. So test will be seeing 1 equals, or it might be seeing 2 equals 2, it might be seeing 1 equals 2, it might be seeing 4 equals 2, and it'll exit with status 0 or 1 appropriately. If you want to do a bit of coding this weekend, you've got, well, no, again, please work on your maths, but if all your maths is done, all your physics is done, all your other courses are done, you could implement tests yourself. It's a fun program to write, actually. It's a really fun program to write. You can write it in a few pages of code, but it's a challenge. Now, what about this square bracket here? Square bracket is the same as test. Cosmetically, some programmers think this looks prettier than putting a test here. So they think, well, no, rather than scratch it in, some programmers think it looks nicer to write this. It's the same thing. It's your call. I actually well, no, I agree. Square brackets probably does look nicer. For 2041 and for teaching, I like to write the test so it's really clear. Separate program, exit status, what's happening, everything. All right. Anything more to say about that program? I don't think so.
I would like to point out that one of the things about square brackets is it looks like it's inbuilt syntax, but it's not. It is a program, and because it looks like inbuilt syntax, people like to go, oh, the spaces are optional, and they forget to put the spaces surrounding the square brackets. but because it's a program, it has the same rules as all the other programs we run, which is that all of its arguments must be separated by spaces. The spacing is still important with square brackets. Is the closing bracket, does it do anything? No, it's cosmetic, but also required. It's a weird little thing that open square bracket requires. You must end the statement with a closing square bracket.
Right. And then sort of, side note, Bash, one particular shell, has a thing with double square brackets, which is a slightly nicer, slightly more features version of square brackets. That's fine if you know you've got Bash. As I said a number of times, I want to teach you about the shell features you'll have everywhere. So if you have to write shell for some sort of embedded device or something like this, then you won't have Bash. The footprint is too big of Bash to get on these tiny devices. You will have a shell, and I want you to know to write programs that'll work there, scripts that'll work there. It's an interesting thing, actually. By the way, shell has actually a pretty small footprint, so it's actually it's not fast. But if you're worried about storage space or it can be actually quite easy to get shell scripts, and that can be the way to go in running tiny little devices. Oh, excellent question, Daniel. Is it Bash that our VLab computers run? I'm not actually sure. Bash is certainly on our systems, but I'm not actually sure what the default you get
Bash is the default at CSE.
Oh, it is. So, sorry, you said bashes or dashes?
Yes, Bash. Bash
is the default.
At CSE.
Oh, you will have Bash. You could say PS, which gives you information about processors, will tell you what's running there. So if you type that on a CSE machine, you should see.
You can also run echo $shell. Will tell you what shell you're running as well.
Now, we've got a nice question from of Blake again. Blake's asking, well, why doesn't test use a less than there? Why does it have -LT rather than a less than? Could do that, but don't forget, less than has a special meaning to the shell. Less than means IO redirection, as does greater than. So less than means take your IO from the file specified after me. Greater than means send your output to the file after me. So they'd have to be quoted. So the test designers chose -LT instead of less than for that reason. There's not a better reason than that. The Bash has extensions to let you use less than. And there's a good point there. Someone's saying, "Oh, I use Zsche," and it's pretty common for people who've done a lot of coding to have strong preferences about a particular shell, and maybe they love Zsche, and it supplies a slightly different set of features for interactive use. And that's fine. As I said again, we'll focus on the core that's in all shells, not just Zsche, not just Bash, all shells. I think I'm done with that example, but so sometimes I show you stuff that's not so important, and if you're struggling in the course, you shouldn't worry about this important, super important. You should understand every last piece of that script. That's crucial core material, is understanding everything in that script. There's a couple of versions on the class web page of that, as well as you can grab this by the link for the live lectures as well if you prefer. All right, okay. Now at start of this year, it became 95 years since Winnie the Pooh was published, which takes it out of copyright laws are complicated, but I think it takes it out of copyright in the United States. So Winnie the Pooh, the lovely book by Winnie the Pooh by A.A. Milne, is now out of copyright. So I thought we'd celebrate that this is the first COMP2041 course since then by doing an example with Winnie the Pooh. Gutenberg.org is a site that hosts thousands or millions, I don't know how many books that are out of copyright are freely available. So I'm going to get a text of that. I'm going to download it into this directory using a program called curl. I've got the link hopefully, and I'll put it in poo.txt. Will that work? Alright, it seems to. Alright, let me say a couple of words. Curl and wget, some of you already had to use them in this week's lab, I think, haven't you? It's a very common thing to want to do both from the command line and also inside scripts is fetch some, do a HTTP request something from a web server. This is a nice simple example, but you may want to do more complicated things. And this week's labs, Dylan came up with some lovely things, I think, for the advanced exercise. That's this week, isn't it? Poking at the handbook API, yes, and introducing you to some nice tools as well. And that's a common thing to be scripting. So this is a really simple example. There are two programs, wget and curl. I like curl for some when I'm doing some sorts of stuff. Wget is actually better for one or two other. It's best if you know about both of them. They're often the first programs you put on a system. So you're configuring a new system, and you have to start doing things with it. One of the first programs you want is curl or wget. Same if you're creating a container. You know, one of the first things you'll put in any container is curl or wget. What else I wanted to show you? There were two options.
I had a great question. In one of my labs this week was, what's the difference between curl and wget? They both seem to do the same thing, and yes, they're very similar. And you can pretty much make one do anything the other does with enough options. They just have basically different defaults, is mainly the difference between curl and wget.
All right. Lisa's asking, which should I use? All right, I'll give it my shot. If you're doing something where you have to talk APIs, headers, you're mimicking, you're debugging JavaScript, anything like that, curl's great for that. So sort of anything related to web front ends, curl seems to be nicer for that. You want to supply cookies and things like that. If you're trying to mirror websites or do recursive fetches, wget seems to work better for that for me. But you may get other opinions from other people. I'd use both almost daily. So let me show you two useful curl options. One I remember is, I think the short name is -q, but the long's -silent. I don't know why curl thinks it needs to give you all of this output here by default, but it's annoying if it's a shell script. It's okay, I guess it's a bit annoying interactively even, but it's certainly annoying inside scripts, so we want to silence. And Rahul is saying -L. -L means if the web server says this page is moved, it's now here, curl will follow it. You're saying, why would that happen? Yeah, I honestly don't know why it happens so much, but it does. So it's another one. So is it -SL is the really common you want. One thing you might do in a circumstance like this, let me show you another common thing. If I want to see what's happening, I might say put it in this file and show me the first of it maybe, so I can see what comes in. And there's using shell scripts to say the first lines. Alright, so that's using curl to fetch a thing, and we can there we are. Winnie the Pooh seems to have 12,288 characters there. I guess we should use tail to look at the end of it and see if the end looks sensible. Oh, that doesn't look good. What's gone wrong with my Winnie the Pooh? Is that really? I'm now worried. How many words? Actually, 12,000 words doesn't seem very many for Winnie the Pooh. Alright, what has gone wrong here? Has Gutenberg let me down?
What's the file size of the one that you downloaded?
Let's try that download again, just sending it straight to the... Ah, that's better. Alright, so that shows you how being proficient with these command line tools like head, tail, grep, WC. You just day to day want to use it to check data. So we'll check that file and make sure we... You're saying, Andrew, I won't be downloading Winnie the Pooh in my job. No, probably not. But you'll be doing similar things. There we go. All right, that looks sensible. So what I wanted to do was I wanted to do a lexical is probably a word, a lexical analysis of Winnie the Pooh and see what words are in it. You're saying, Andrew, why would I, again, and again, maybe that isn't literally something you'd do, not literally, so, well, it's a poor choice, exactly, but it's actually analogous tasks are really common, really common. So I want to pull this apart and see what words A.A. Milne used in the text. Blake is saying, if it sounds like a 2521 assignment, let me tell you they stole it from me. Well, stole. In fact, it's inspired by things we've long done in this course. All right, I've got a problem here. I've got lots of tools like sort and unique and things like that, but they all work line by line. If I'm interested in words, it would be much better to have the words one lined on a single line. And there's a way to do this. Let me show you how you might get words on a single line. What happens if I turn spaces into new lines like this? So I've done that. Let me make sure I've chmoded that file. I seem to have. So let's run the file. I'm going to build up a shell script to do this analysis. And we'll run it from poo.txt. You see what I've done there? I've told TR does a character mapping. So it says map this character to that character. You can also say just delete characters, but it does things character by character, which is really useful because there are a lot of tools that are line based. SED's line based, Unique's line based, WC sort of, sort. So TR can be quite useful there. So I've got these things one per line. What else do I want to do? Well, how would we count all the words? Murphy's asking, what is Chmod 755? Yeah, sorry, it is a thing with. I'll give you a quick thing for that. Sitting here are the permissions for the file. By default, you can't execute a file. You want to add that little X. Those ones are for the owner. These are for other people. That says the owner of this file, which is me, can read, write, and execute the file. Everyone else can read or execute the file. That, if you've been doing this for a long time like me, you type it out as a base 8 number. There is a better way to do it if you're not don't find base 8 natural. I could have also said that to say make this file executable by me.
The shortest way is also just +X. Generally also works.
Oh, good point. You can. I didn't even know that because I always just type the bits I want. All right, which is not what most people do, quite possibly. So what about I do this? This should that should give me. All right, it's exposed some problems. Actually, we don't need on back. It's exposed some problems, but there's all of the words. Well, words, yeah. What is a word? There's all of the words in Winnie the Pooh in sorted order. Now I'm a bit worried here because u full stop is a different word to u comma. So it'd be nice to delete everything but letters, wouldn't it? How would I delete everything but letters? I can do that with tr-d, and I can say delete, oh yeah, everything but letters. That's probably what I want, isn't it? Let's try that out. Nothing can go wrong with that. Oh, except I think tr wants, is that what tr wants?
Well, that says delete letters, not everything but letters.
Oh, thank you, Dylan. There's another option to tr which is complement, which says delete everything but letters. That's this time for sure. Though I'm a bit worried about mystery and things like that. So maybe I should be doing something with uppercase letters. But let's... Oh! What went wrong there? The letters got through. What did I delete that I didn't want to delete? Hint. I deleted the new lines. TR is great, but it's character based, and I said delete everything but letters, so TR is happily deleted new lines. So I can say to TR delete everything but letters and new lines. It's looking much... Oh, I'm a bit worried about these. What? Excuse, exercises, expedition, explains, exposition, expo what? Expo whatever. What's happened there? I've got a theory. Oh, an history. I think this is relating to uppercase letters. So let's see what we can do here. I'm suggesting that if we change the uppercase letters to, well, actually first let's just not delete the uppercase letters. That's probably what we want. Now we're seeing a different problem again. By the way, if you're thinking, oh, this is so stupid, I just write the code normally and it'd all work. No. This is normal. This is every time you don't know what the problem is until you start to solve it. The problem's not sure, a first year programming exercise maybe, or an exam question maybe. The problem is so clearly set out you can write the code. But much more often you'll write the code and discover something about the shape of the data, the shape of the inputs, or perhaps something that's unspecified, and then have to modify what you're going to do. So it's a process, an evolving process. So here we've got problems where the dot there is gone, or the apostrophe is there, and it's lumping things into words. So I think my idea of deleting these things, I really probably wanted to turn them into spaces, which I don't think I can do easily with tr, or maybe I can, but let's do it with sed. Let's switch over to sed, and we'll say to sed, you get anything that's not a letter, turn it into a space, and do it everywhere on the line. Let's try that out. But I think we need to do that before we turn spaces to new lines. Alright, that's my next plan. Looking a lot more promising. But it's often useful to look at the head of the output. So we've got these capital letters. Case, in any sort of processing of text, case should be always a question. So I've said you're doing a comparison, a string comparison. It doesn't matter what language. It can be Shell, it can be C, it can be Python. It doesn't matter what language. You're doing a string comparison. You should be asking yourself, does case matter? And half the time at least, case doesn't matter, and you really want to ignore case. So you always should be thinking about case. The same applies to sorting. The other thing you should be thinking about is white space always in these things. Should I be cleaning out white space? So TR is quite handy. We can say to TR, map uppercase to lowercase. And now everything's in lowercase. So we're starting off with A. And we're finishing with, alright. There's some suggestions in the chat which are very good, but we're not going to go into. If you fetch, there's a version of this script that's done in a nicer way using character classes, but we won't get to that. So yeah, don't take it as this code in front of you is the best way to do it. I'm trying to write things in a natural way. I'm trying to write the most understandable code, and often, and this will be the case right through the course, often there'll be the example in the class website will be better than the one I produce in the lecture. But I've added here my favorite unique option. Unique has an absolutely wonderful option that says include a count. So not just tell me that zoo was in the input, include a count of how many times zoo was in the input. You're probably quite familiar with that from previous labs. I hope so. I hope you're familiar with that from previous labs. Now it'll tell me how many times zoo gets mentioned in Winnie the Pooh. 3 times. Alright. U gets mentioned 46 times. 2 is... Yeah. Now, I'm really interested not in alphabetic order here, probably order frequency. I want to know what Winnie the Pooh's really about, really understand what A.A. Milne was trying to tell me. So I'm probably interested in seeing the most frequent ones first. Oh, wait, that's not good. What is that? I don't know what that is. Wait a minute, I can find out. Cat minus A will show me the non-printing character. Oh. Does Winnie the Pooh have 17,411 empty lines? I don't think so. I think my issue is here. I turned the spaces into new lines, and that can produce an empty line. Oh, how do I get rid of empty lines? How would you filter out empty... How would you say... Well, how do we filter out lines? grep is our program for printing a subset of lines. So grep reads input, writes output, reads lines from input, writes line to output, but only writes a subset to its output. Yes, Tim's saying squeeze multiple slash n. Yeah, there are ways to do that, but grep is so lovely, grep is so obvious. How do we say print only I could do this. Here's my first go. This is perhaps the most obvious. It's not necessarily the best. But what about I say this? Match an empty line and then invert the match. So that's it. That would print only empty lines, but I've inverted it and said print lines. Let's try that out. Does it get rid of the... Oh no, did I write the file? Should get rid of it. Ah, there we go. Jaden's got a suggestion. Dot plus. You can do better, Jaden. You can do well. Actually, all right. Now let's roll with. Jaden's one has said dot plus. We'll try it out. Jaden has wisely said, put the dash e, which we often want because plus. Oops, I've said star. Jaden wanted plus. Yeah. So that's right. That says one or more characters. But let me show you. You actually don't need the plus, because grep matches any part of a line. So that says, is there any character to match? And that would work. Though I like the dot plus. I really do like the dot plus. And actually it sort of makes more sense, but just dot works. Someone's saying, you can do it with sed, Andrew. Yes, sed is, yes you can. It's actually not that hard with sed. Anything you can do with grep is not that hard with sed. Sed is Turing complete, so you can do anything with sed, but anything, no. Most things you can do with grep are pretty standard in sed, but we reach for the tool that's simplest, most obvious, like that. And if it's just a dot, we don't need the extended. In fact, I'd leave the extended there. I certainly would never ever criticize a student for having the -e flag and not needing it. Never. All right. Oh, what I want to do is sort these in order of frequency. And I'd say sort -n. You actually don't need the -n probably, because the numbers are right justified, but sort of makes sense. That should give me frequency. Oh, maybe we'll reverse the order though to get the most frequent first. All right, any bets on what the most common words will be in Winnie the Pooh? Yeah, and then oh yeah, lack of gender inclusivity there, isn't it? Piglet coming down at 225, half as interesting as Pooh, with Robin a bit further down. Oh, Eeyore getting left out down here. All right. So, yeah, while you may not be doing much linguistic lexical analysis of novels, Winnie the Pooh or otherwise, these are classic sort of commands. They can be written in various other ways. Look at the example on the website to see other ways of doing these things, but that's a classic piece of programming, all bundled up in a shell script, but I thought that was nice to work through. Now, all right, and a snapshot of 1920s language for you. All right, I think I need to take a short break from talking. So let's have a 5-minute break. Why don't you walk outside, enjoy the mild day, or at least open a window or focus into the distance. 5 minutes break, and we'll be back. So talk to you then, where we've got so many more examples to go through. Alright everyone, welcome back. I hope you had a little break. Alright, more examples to go. Oh, there's a question. Yeah. So Dylan was saying Daniel's question was really great. So let's... and this is actually not a bad one to address it. So Daniel's question, I think, was, yeah, how does input work with a shell script? The answer is, if I run, say, countwords.sh like that, any program, yeah, it's a great question, any program in here that reads from standard input will read here. So often what we want to do, if we want a shell script to read from standard input, is we just put the command there. So I've got a tr there that will read from whatever the standard input is of the shell script. So I can type in words now, A, B, C, I'll put another C, and I get a count there that there were 2 C's, 1 B and 1 A. There's a design decision being made with this shell script, whether it's should it look at command line arguments or should it read from standard input. It's a design decision. In this case, this shell script reads from standard input, more precisely this tr. You're saying, Andrew, what about that sed, what about that tr, what about that grep? Well, look at the pipes. So the shell script says, you know, this sed is reading from this, but if there's a command here, the shell will read from it. A classic mistake to make is, you know, to put a grep here and forget the file, and then the script suddenly starts reading from standard input. So if we get a shell script wrong, we may be writing a shell script that's not meant to read from standard input at all, but if we get the arguments to grep wrong or something like this, it will start reading from standard input. So that's something to watch for in your debugging. Excellent question. Alright, thank you for that, Daniel. Let's move on to my next programming problem, which is, let me give you the context, a bit of a fake context. Well, so we're waiting to get in to enroll in this course. There's a university, so here is supposedly a UNSW web page giving the number of spaces available in various comp courses. And look here, there's no spaces. Note this is not a UNSW web page. It's actually hosted coming off my local web server. We'll see, so I can update it on the fly. And this is a really, really common thing to do. Is we want to work on something like this, we'll set up something on a local web server and muck with that before moving out to the wider world to try it out on the wider world. So we'll use our local server as a test bed. So I've got notionally this. Now at some stage this web page is going to update to say, you know, there's 3 spots in COMP2041 or perhaps spots in 9044 further down. So I want to be told when that happens. So I'd like a shell script to watch the web page for me. So I want to write a shell script, watch website, that monitors a website and lets me know when it changes. Now it occurs to me this is incredibly useful. So I'll write a bit more generally. I want to write a shell script that takes 3 arguments. It's given a URL of a web page, a regular expression, great use place for a regular expression, and an email address. And when the regular expression matches against the contents of the web page, it sends an email to the email address. And my master plan is I'll leave this shell script running and it'll keep watching, and when it notices when the irregular expression matches, it'll email me saying, you know, Andrew, regular expression matches, and then I can enroll in the course. Alright, let's look at how we might do this. We don't know what the regular expression is, we don't know what the email address is. Well, don't worry about this. But you can think, Andrew, I've seen some of the tools, wget or curl. So we might use .curl and we saw -SL are nice options, and the URL. Let's see what that does. Alright, let's try that out over here. Watch website for the URL. I'll cut and paste it in. There we go. No HTTPS, no security at all. Alright, so we're going to our web script is fetching this. Then I guess we grep for the regular expression. So, just a word of advice, URLs do contain characters that are special to the shell. That one doesn't, but they can, so you're probably better off quoting URLs. It's okay here. So what do we do? Well, we can then pass that to grep -e and the regular expression, and put a $$ on the front of that. Alright, so our regular expression might be COMP2041 or 9044. A bit longer. There we go. That's matched. Oh, so we've got to come up with a regular expression that matches only if that's non-zero. I can do that. I'm on that. All right. All right. Now I need a way of updating the website there, which I can do. Oh, that's not where I wanted it. I wanted it here. Bear with me. My head will be mainly on this, but that's okay. On a Linux system, the default files that the local web server serves are in this directory. You'd almost never use them, and there are lots of other things you can do. A common thing to do here, by the way, if you use Python, you can spin up a web server in one line of Python or one line of Node. But I'm using Apache, which is a bit overkill. Alright, so let's say there are 5 vacancies here. Change the file to say 5 vacancies in COMP2041. Confirm it updates here on the web page. Yeah, it's updated now to say 5. Now let's see if our regular expression now matches. Oh, look at that. The regular expression is triggered. So we have a sort of proof in concept of we can use curl to fetch the web page. We can use grep to search the web page. We've got a regular expression. It's a bit hacky. It's a bit brittle. It's a bit... but it works. It only matches if there are vacancies in COMP2041. You're saying, is this the best way to do it? And we could have a whole lecture on pulling apart HTML, but shell scripting is the point of this lecture. We might come back to that. All right. So now I want to work on the monitoring aspect, having the script sit there until there are vacancies in COMP2041. Sit there repeatedly fetching the website. So we'll go back to there being no vacancies in the course. Let me demonstrate that. Oops. No vacancies in the course. Actually, we'll move that across as well. Oh no, that's okay, we'll leave that. So how do we do this? Alright. My motto is, if in doubt, reach for an infinite loop. We won't actually implement the sending email, but we'll put it there. Alright. That would be another message of this, yeah. Something like this, you'd never try and write it all in one go. You'd write it in parts, and even this sort of debugging code where you don't send the email, you'd turn that into diagnostic information, or have an option to say, you know, test it, which doesn't send the email, just prints the message. So alright, so that's my plan. Now, I'm not even going to run this. This is something I really wanted to emphasize and warn with you. This sort of thing is a trap. It's something to avoid unless you want to be malicious, which I'm sure you don't. So this is bad because this is generating requests to the website as fast as it can. So it's sitting there in an infinite loop making requests. You're saying, what's the difference between this and a denial of service attack? Almost zero. The only difference with a denial of service attack is they'd probably try and multi-thread it and use thousands of machines. But this is hammering the website, request, 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 and it's unnecessary. We don't need to know instantly. I'll put here a 1 second sleep, but in a real script we'd probably set it at 5 minutes. So sleep is a command that says to the operating system, wake me in this much time. And in any of these, it almost always, if you're doing these repeated activities, you want some sort of sleep in there to rate limit it, control it, make it much more acceptable. That now will generate, instead of maybe 1,000 requests a minute, 60 requests a minute. And as I said, it probably should be 5 minutes or something like that. A sleep takes no resources, by the way. The operating system does it in a very efficient way. So it's nice for our servers, or nice for the computer. It saves power if it's a battery powered device. If it's a device you're sharing, it lets other users use it. If you're paying for CPU used in a cloud situation, it avoids costs. So sleep is a wonderful thing to delay when we want to delay. I've said, all right. Now there are a couple of questions here. Oh, there's a huge one. There's an elephant here that I haven't mentioned. So how does an if statement work? If statement executes command and does the then part if the command has exit status 0. So if this exits 0, this is executed. But there's two things here, Andrew. 1, 2. Which? It's the last thing in a pipeline that determines its exit status. So it's the grep. Was there some way to know that? Should you have just realized it? No. It's a choice. It's a complicated choice. It works well for grep. It doesn't work well in some other situations. It depends really what's yeah. So sometimes that's a win for you, other times it's not, but you always have to know for a pipeline it's the last thing whose exit status matters. So if that's not what you want, you may have to do workarounds, but we're lucky. Okay, let's try this out. Let's clear the screen, power it up again, set it off watching the website. So it's ticking over watching the website. Do we know it's doing anything? Alright, for our first execution we might want to turn on, oh, I know what we can do. Look at this. So we know the script is doing something. The -n says no new line. Oh, look at that. Dots ticking out. That's great. So we can see the script's doing something. Alright. Let me change the website. Let's say there are places in 9044. Let's make there be 7 places in 9044. I'm going to write this file, which should update the web server, and the script should trigger. Let's try it out, hitting return, and the script triggered. Alright, let's try that again, but we'll do a couple of things. Just to we'll set the email address. We don't want the output from the grep. And there probably is a grep option to say, I don't want your output, I just want your exit status. I think there is a grep option for that, but as I can't remember it, look at this trick. That says send standard output to dev null, my favorite special file. Think of it as a black hole. There's no return from dev null. You can write as many characters into dev null and they go nowhere. You can also read from dev null and you get nothing. So it's just a dead end on every Unix-like system. It's a good way to get rid of unwanted bytes. Let's try that again. So it's there ticking over. This time we'll put the places in COMP2041, sorry. There we go. We'll say there's just one space here. Oh, wait. Did I write my file? I mustn't have written my file. Let's run it again. And I'll specify the email address as my email. There. So we've got a script that will sit there patiently watching the website until it contains this regular expression, and it will do this command when it happens. Can you code that up in C? Sure. Can you code it up in Python? Yeah, it actually wouldn't be so. It'd be a real mess in C. Python, not so bad. In Shell, it's just natural in Shell though. It's lovely in Shell. So that's using a while loop. Was there anything more I wanted to say about that? I don't think there is more I wanted to say about that. I think that's a nice example. The only thing I would caution is, yeah, that should be something like, you know, sleep 2 minutes, or maybe don't hammer people's websites. Be respectful. If you want to do something less, you know, sleep for 10 minutes or whatever. Make as few requests as you can. You will discover, by the way, lots of websites have trigger protections if you don't make too many requests. So making one request a minute or something like that may avoid you being locked out for hours or days. Good. Can you structure that into a while loop? Maybe you can, but I think that's actually more obvious code, and I like obvious there. So that's a nice shell script. Right, let's move on to my next problem. My next problem is, I had an accident. Something happened in this directory where all the files got turned to uppercase. So before we go into this, Tim's asking, would you use cron tab for this? Yeah, so it's a nice question in the chat. Yes, I would. Well, would I? Yeah, maybe. Cron, just for mentioning, cron is a Unix program that exists to run programs regularly. So across a system, there are programs that mean to be run hourly, daily, weekly, monthly, rather than everyone have their own system to run things periodically. Cron is a system-wide implementation where you can say to cron, run my program every Monday. And sure, so it's something you wanted run every hour, you might ask cron to do. So yes, interesting point, Tim. You could do it with cron. All right, back to my problem here facing me. So I could sit here renaming all of these files manually. I could sit here typing, you know, move book to book and so on. But that's a bit tedious. I'd like to write a program to do it. Can we write a program to convert file names to lowercase? And I think we can. So let's get started. Oh, that's not good. How do we loop over our arguments? This is, as a reminder, this is a loop that goes over our arguments. Alright, this is an exam or a practice, a weekly test. It's not a bad idea to write, confirm we've got everything happening. So that loops over all our arguments, and oh no, that's not what I wanted. Already I'm confused. So let's try that out to see if we've got the right loop. Ah, it's in the next level up. Oh, it's not auto completing, it must be. What you missed there, I know that it wouldn't, the file name wouldn't autocomplete with tab. The shell's smart enough not to autocomplete a file name with tab as a program if it's not executable. I made it executable, it autocompletes. Don't worry about understanding what I'm saying, but try these things out for yourself with a tab. Dylan, I hope students' shells are set up by default to autocomplete with tab. Are they?
Bash does it on a command by command basis, so it's on most.
So they are set up with bash auto completion. Nice. All right. So I've got a loop that I can get to execute once for every file in the directory. How do I convert? Oh, thank you. How do I convert a file name to lowercase? Well, you're saying jumping up and down. Andrew, I've seen it. We did it in that just example like that. So we can get the file name in lowercase just like that. How do we capture that? Alright, so here's a crucial thing we can do. We've seen this, but let's see it again. We can capture the output of a command with dollar brackets. Like this. So dollar brackets, there are a few issues there, but the big thing is this: dollar brackets, close brackets, runs the command between, treats the words between as a command, a shell command, runs them. You're saying it's a shell command? Can you put a loop in there? Yes, you can. Whether you should, separate question. But any shell can go in between those dollar brackets. It will get run, and whatever it outputs will go there. So this will give me the file and the lowercase file. Let's see if that does its job for me. And it's doing it. It's doing it. Everything's great. So it's saying this is the uppercase, and this is what you want, Andrew. This is uppercase. This is what you want. This is what we've got now. This is what you want. Look at that. This is what. All right. And here's my plan. Look at that. So there's my plan. Let's try it out. It's going to go badly wrong. There are about 5 things wrong with this, or more, but 6 now. Let's try running it and see what happens. Oh, that's a bit weird. Alright, let's run ls. Seems to have done the job, but where's book? CP gave me an error message. Book and book are the same file. And that's weird. I don't know what happened there. Try it again. Oh. Where are all my files gone? It's destroyed all my data. Alright. So I've lost all my data. Alright. Now, often the reaction is, oh, I should not make mistakes like that. But yeah, this is a particularly stupid mistake if you've been coding for as long as I have. It's a perfectly normal mistake if you've just learning to write scripts. But the moral is never, I'm not going to make mistakes. You're always going to make mistakes. The moral would be, have backups, don't work with important data. So you'll sooner or later destroy data. Yes, a few people have spotted the mistakes. Before we go to the mistakes, spotted in there, Lisa has got a nice point in my CP. Lisa's saying, Andrew, you should have a -p there to preserve permissions, because if this file was executable, the new file may not be. Yeah, excellent point, Lisa. So that's just the sort of 2041 thinking we need. It's not just copying the contents of the file. Files are more than just contents, there's metadata. So we wanted a -p there. The CP, though, is a bad idea. There's a few bad ideas. There's a few things I wanted to work on here. I have to get the files back. Well, actually, I can just create, well, no, I can get the files back. I think I did them with xargs, so it'll probably just come up. There we go. Right, the problem is if there's a lowercase file. For those of you who have forgotten, touch can be used to create files. So I'm just creating fake data. They're actually all empty files. Really common thing to want to do. Actually, well, let me show you this command. What does this do? I just wanted some file names, so I said, what do we do? I'll get all the file names from directories 2 levels up, convert them to uppercase, and I'll create them. So it's a cute little command to create fake files. They're all 0 length, but that's all we need for this example. Now, let's move to the big thing, the huge thing, the thing you should really be listening to if you want to write robust shell scripts that don't destroy your employer's data, so you have to have bad conversations with your manager. Robust shell scripts that don't, well, you don't have to put in the lame special consideration, you know, can I have an extension for my arts essay because my COMP2041 assignment destroyed it. How do we avoid that? One thing is, we think about in shell scripts, what happens if this fails? You should always be thinking, do I want to keep executing? There's actually a shell option. You can put a -e up there, and that says just stop if anything breaks. So that's one possibility. We won't do that, but you should think about that. But we should be asking ourselves, you know, every command we run is, should we keep going? The classic one you see is code like this. You'll see code in shell scripts that goes something like cd to var temp working on this. All right, I've seen so many scripts like this where the script goes to, you know, a temporary directory where files that are not needed are stored, then says rm star. Okay, that's great 99.9% of the time. what happens if you run this on a machine where that directory does not exist? You destroy all the files in your current directory. The CD fails and you destroy all the files in your current directory. That is bad, bad, bad. What can we do about this? I'm not sure we talked about one of the shell things provided for this, and I might bounce to my slides to tell you about this. Not test, if, while. See, we talked about this. Example 4. Conditional execution. Alright, commands are mostly in shell scripts separated by semicolon or new line. They do exactly the same thing. That just says run command 1, command 2, command 3. There is alternatives. You can use 2 double ampersands, and that's will only run the second command if the first command succeeds and exits with status 0. So you can chain commands together, and the execution will stop if any of them fail. So if command 1 exits with status 0, then command 2 then will be executed. If it exits with status 0, then command 3. So that produces execution that's conditional on the previous command succeeding. And you can also use double OR, which produces execution on the previous command failing, exiting with a non-zero exit status. So double and double OR, really, really underused by shell programmers. There are too many people out there writing out shell programs who don't think about this, and they've got programs that work 99% of the time, and then 1% of the time they destroy the world's data. I don't know what the movie was. It's quite an old movie, but in the making of one of the early Industrial Light and Magic movies, someone wrote a shell script. It wasn't this, but it was the equivalent of this. It wasn't much. It was almost as stupid as that, which destroyed all of their work on the movie. They'd made 3/4 of one of I think the Toy Story movies, or maybe, and it destroyed much of the movie. Their saving grace was a key coder had gone on maternity leave, and she'd taken home a machine and she'd copied the entire movie onto her machine to take home for. So this 9-month pregnant engineer had to come in clutching a bubble wrap machine which had months and months of work on it to recover it, because someone did something like this in the script. Sorry, it's a interesting story. But so what do we do to avoid this, and to avoid dragging engineers off maternity leave with our only copy of 6 months of work on a movie? Well, we could do something like this. This is pretty simple. If that fails, exit 1. If you're pedantic about, some people like to in fact I like it to indent like that. I don't indenting's a, who cares that much about indenting, but doing this, if the CD fails, we just want to stop. We can't go any further, and we definitely don't want to do an RM star. So we can do something like that. All right. So that's using or. That was sort of a fake thing. What can we do here? We can make the RM conditional on the CP, and that would avoid our big problem. So that and said remove the file only if copying it worked. So yeah, don't destroy data unless you're sure that previous commands have done whatever you need to do. So yeah, think about that always. Now there is an issue with CP anyways. It's generally copying files is like this. It's sort of to be avoided. There are multiple issues, and Lisa highlighted one of them, talking about permissions not being preserved. A better alternative would be a move. So a copy is a sort of an expensive thing. It actually copies the bytes of the file. It's a different operating system operation. A move does a file rename, and it has nicer properties in a number of ways. We like moves. Copies make us nervous. One thing, why do copies make me nervous? If we're working with live systems and I copy a file, I'm worried about other programs will look at the big file in the middle of its creation. So a program will look at the file half there and bad things will happen. Whereas a move is I'd call it an atomic operation, where it's not possible for a program to look at the file halfway through its move. It's an indivisible thing. You can't have anything happen while you're moving. The real world is a bit more complicated, but it's move certainly a million times better than copy. So I'd say that. All right. So that's a better version. That won't destroy data. Well, or will it? Post in the chat if you can think of a way that script will still destroy data. There's two obvious howling errors in that script. Let me run it now, and it'll point out an issue with the script still. Oh, maybe I haven't written this. What happened to file.c? Oh, it's still there. Oh, I didn't give the script any arguments. All right. So we're getting an error there from move saying file.c and file.c are the same file. Let me show you two ways out of. There are a few ways out. There are 3 ways out of this. So move may have an option to say don't produce error messages. So we can say man move. Is there a quiet option? Oh, doesn't look like there is. If there's not a quiet option, we can actually send its output the standard error. Sorry, you can send its error messages. We can send its standard error to dev null like that. That says redirect file stream to, which is standard error. You're thinking, shouldn't that be a name? It never really occurred to me. It's sort of embedded in programmer hearts that 0 stood in, 1 is stood out, 2 is stood error. Perhaps it shouldn't be, but that's a way to direct the error messages and get rid of them. On the whole, I'd be very reluctant to do that because it's so common that do that to get rid of one sort of error message, and something you haven't thought of is producing another sort of error message and you don't see it. So I would prefer to do something like this: test $file not equal to $lowercase file, and then that, and that will avoid the problem. Let's try it out now on file.c. And I can actually run. You can run -x on the command line like that. So that's another nice trick. As well as putting set-x in the file on the command line, you can say shoo -x and see. Look, you can see it doing the test and the test failing, so the move not happening. All right. And people have been diving in with how my script still destroys data. All right, and let me show you. If I've got Andrew.c, Andrew.c, and Andrew.c, how many files will be left after I run the script? Just 1. So it's silently destroyed this. So there's 3 files that are all turn into the one lowercase thing. We have a feature request from Blake of creating a unique name for the duplicate ones. Yeah, that's a perfectly sensible thing to do, but not something I'm going to be able to get to. Move has a nice option to say don't do that. I think it's the -n option. We could enable that. but I wanted to do something different. I'm going to change my logic here. Let me show you slightly different. If the files are equal, I'll continue. Shell loops have continue like Python and like C. I can also say test if the lowercase file exists and do something then. So this is another way to write the loop. Let's do this right. There are things wrong with this shell script too. This sends the output of echo to standard error, which is a bit nicer. Probably doesn't matter much here, but just doing things with a little style. There we go. So that's my full logic. If the file is the same in lowercase, just keep going. If the lowercase file exists already, we should say we put out an error message. Otherwise we do the move. There is the question of what happens if the file is created just here. Whoa. So we'd probably, anyway. Oh, I want to recreate those and say, oh, so close, so close. Oh, it's the equals up there, not a legal operator. Let's try that this time. All right, that could do a continue instead of exiting, but that's got a lot of the logic there. As I said, I'm not going. It's perfectly sensible features suggestion to have it append a number or something like that. Daniel wants to move the files to a temp directory, then grep for file names. Yeah, there's lots of things you could do. All right. There's one huge thing wrong with this script. I can't see if anyone spotted it. There is one thing I've forgotten in this script. Maybe we haven't mentioned it much. All right, let me show you. Let's create a file called So I'm writing a successor to I.A. Milne's Winnie the Pooh. It'd be better if I could spell Win. Sure. With a single quote in the name as well. There we go. Will that work with the script? Autocomplete for my shell backslashes the spaces and the single quote. You could actually use double quotes there as well. But will that work? How weird. What has happened there? Test Andrews unexpected operator. Someone's suggesting, I think it was Tim was suggesting, it's a single quote. It's not actually the single quote, but yeah, good thinking. You worry about this is the thing. You worry about special characters, weird characters, what's interpreting them. So it's something we'd include in our test cases. We'd include it in our thinking and analysis. So I can do the shoe minus x and see what's happening here. what's happening here relates to what the shell does and the order the shell does things. I'm almost out of time, so I don't have time to go back to the lecture slide. But the crucial thing is here is what's happening. I've said $file. The shell replaces $file by its value, replaces $lowercase by its value, and then, it's a big then, and then it splits the line up into words and passes each word separately as an argument. So how many arguments is test getting? It's not getting 3 arguments, file equals lowercase file. It's getting many arguments. Each of these, so it's been given Andrews, it's been given great, it's been given novel. So test is looking at this and seeing, oh, this doesn't look like an expression to me. There's all these words and no operators. It's seeing this is a separate word, this. What did we want? We didn't want that expansion to happen, so we want double quotes there. Now, if you're thinking carefully, I'm sure you are, thinking, well, I probably don't want that expansion most of the time. 99% of the time, you don't want the expansion. 99% of the time, when you say $variable, you want double quotes around it. Alright, so it's possible you know that the variable can't contain spaces or other special characters. If you know that, you don't need them, but honestly, why would you bother? Every time you use a variable, just put double quotes around it. It's tedious.
$hash is a good example of something that you know can never include spaces in it.
Nice example. So, have I got all of them? Well, actually, no. There's one. There's a weird one here. I need them here as well. So that stops this expansion. Is that tedious? Yes, it is. Does it introduce bugs and security holes if you don't do it? Yes, it does. It's a common source of security holes and bugs. That will make the program work. I think we can show you the execution happening. Oh, the -x output's a bit disappointing, but it's passing now one argument here as test equals the second argument. So test is just getting 3 arguments here, and the script works. So that was that was a big equals. The echo line doesn't. Yeah. All right. There are lots of questions here. We're out of time. Sorry. I think I've got all the double quoting on the script right. If you look at the lecture example definitely has the double quoting done well. There's a program called shell check, which will actually flag bad double quoting.
The echo line does need quotes, otherwise echo will squash repeated spaces.
But I want the
if you didn't have Tim was saying, does it need quotes? And it does. Otherwise, the name it prints out may not have spaces kept.
Often you'd put fake little quote. That's for readability. Actually, I'll take those out. We'll just leave it. But yes, we do. It's possible our file name, our name $0 could have spaces in it as well. All right. Sorry, we're out of time. I have to go. You have to go. There's so much more to talk about. I've got a couple more wonderful shell scripts, like 4 or 5 more wonderful examples of shell programming, things that work really well, are really nice in shell programming, and cover important lessons about how to write shell well, which you'll get to practice in next week's lab. So we'll have next Monday's lecture, and then for me to cover some more stuff, and then you'll get to do more coding of shell in next week's lab. I'll talk to you all next Monday. Thank you for tuning in. See you then.